Hi, this is your host Swapnil Bhartiya, and we are here at the Red Hat Summit in Boston, and we have with us today Melamie Shimano. You are the creator of a food computer program. Is that correct?
Yes.
So is it about food? Is it about computers? Is it about programming?
So actually it's all three. It's a little bit of everything. And I know like food computer is kind of a strange term and sounds very futuristic, but essentially, so the food computer is this open source project from the MIT Media Lab, this group called the Open Ag Initiative. And it's essentially a tabletop greenhouse that's climate controlled with computer programming and robotics. So we grow food inside using computers, not 3D printing food, although maybe that's in the future. But yeah, so basically we use Raspberry Pi. Students in high school during their science classes, we learn some basic programming, some Python, like physical computing type stuff. We talk about food systems in general. So specifically in Baltimore, there are a lot of food systems challenges. So food inequity issues, food deserts or healthy food priority areas. And so we kind of try and tie in the technology, what's happening in the environment around it, and show how you can use technology to, how you can effectively use technology to improve community situations.
Is it about food production or food distribution? Or
The food computers are basically like a box, a tabletop greenhouse, and we use the Raspberry Pi and some sensors, fans, grow lights to essentially grow plants with hydroponics, so with water and not soil inside this box. So we kind of turn the lights on and off depending if we want to basically mimic an outdoor environment inside of this box and talk about urban agriculture and how you can use technology to improve food systems in Baltimore. Because we're in a city, we don't have a lot of farmland, but we have a lot of people. So how can we improve food systems with technology and using Baltimore kind of as our canvas?
I mean, different kind of plants, whatever. They need different kind of treatment also, from the...
Right.
So when you are using Raspberry Pi and sensors, do you like program it to work in that manner, or you're using some kind of deep learning and machine learning technologies also? How does that part work?
Yeah, so what we're doing is kind of like basic programming. So we're saying, okay. We want to capture the temperature. If it's too hot, we want to turn this fan on. If it's too cold, we want to keep the fan off. We want to turn the lights on and off to mimic an outdoor environment, so daytime, nighttime, and we can kind of extend it or compress it if we want to say, okay, we're growing plants that should have more sunlight, or if we want to even test out different types of light wavelengths, so if we want like blue wavelengths or red wavelengths, to kind of see how plants behave in different environments. So we can basically make the growing more efficient. So if we're trying to grow a bunch of plants in a city in a smaller space, how can we do that with the least amount of materials? So if we have a huge field, obviously it doesn't matter as much if we kind of have some plants that don't grow, but if we only have a small basement to grow a bunch of plants, we want to make sure that we're using all that amount of space efficiently. So how can we kind of edit the environment to help us do that?
Does that also mean that, I originally came from India, and a lot of crops grow there, almost everything grows there, but a lot of things don't. I like gardening, but I cannot grow them. So does that also eliminate that problem that you can grow almost everything because you are creating a kind of virtualized environment for that?
Yeah, so that's the kind of the end goal. And right now, so there's still a lot of research to be done, I think, on hydroponics and how to grow a lot of different things. Although we can pretty much grow almost anything with hydroponics. So a lot of things that we grow are like herbs and leafy greens and tomatoes and stuff that are a little bit more resilient than other plants. But the idea is that kind of using this technology and then with the Open Ag group at the MIT Media Lab, kind of on a larger scale, if people are doing this around the world, you can start to build in things like machine learning and say, okay, that we know these are the plant characteristics that appear when you use this type of lighting, or these are the plant characteristics that appear when you use this temperature instead of the normal temperature. And so from that, you can kind of grow different kind of tasting foods, different growing rates of foods, different like yields, like plants have more leaves or whatever, and kind of grow that network and scale food systems that way.
Right. That's how Matt Damon grew potatoes on Martian.
Excuse me? Oh, yeah.
When we look at food production, what do you, since you're working on this project, so I wanted to ask, what is the bigger problem in world? Because there are countries like India, Africa, and all those other countries. They do grow, but their problem is not food production. But they don't have access to a lot of latest technologies. So it doesn't rain, and their whole crop is ruined. Or it snows, so it ruined the whole thing.
Right.
So that is so. What do you think is the actual problem? Number one. Number two is, do you think that the work that you are doing here might also go beyond the labs and actually help the field, or you just want to have it as a backup plan for Elon Musk or somebody when we move to Mars?
No. So I think the bigger picture is kind of we're seeing a lot of cities go into this kind of like smart city, technology city era, and they're like realizing we need to use data analytics, we need to use new sensor technology, we need to use machine learning type stuff to make cities better to live in for everyone. But I think one of the problems with that is that the technologies that are developed aren't necessarily developed within the cities and within the communities that would benefit from them. And so a lot of times we're kind of transplanting in all of this stuff that will work in maybe one city, but maybe not in another city. And so the bigger idea is that if we can start to have students learn about technology, learn about how it's applicable in more than just like applications on your phones or websites, how you can use technology in real life, they'll start to kind of think through, okay, this is how I can use technology in something that isn't like a tech thing, and start to develop the technologies that would benefit their communities from within instead of kind of from the outside in. So
do you also envision a future where all of us will be growing our own food?
I don't know if everyone would be growing their own food, but I think
most of us.
Yeah, I think a more distributed plant ecosystem would be.
The reason I'm asking is that it might sound like immediate technical experiment, but I'm also a science fiction writer, so I'm also looking at for the larger picture also.
Okay.
So do you? I mean, or I'm on a totally different tangent, or do you think that what I'm saying it does make sense? That you are looking at something like that as well.
Yeah, I think it makes sense because right now you can pretty much get food at like grocery stores or farmers markets. I think it makes more sense to have kind of a distributed agriculture food system. So if we're saying maybe not every single person, maybe we don't go back to every single person have their own farm, but we have kind of like central hubs. So every single school has a farm that like everyone can kind of use as their own produce market, or churches or community centers can be hubs where we're using technology to like grow food in the basement of every single one of these buildings, therefore like providing healthier food to people without needing to like build the infrastructure for a grocery store or drive in a bunch of stuff from fields outside.
Yeah, I think that's a great idea because it will solve a lot of problems, because mass production always lead to a lot of corruption.
Right.
And a lot of quality control issues come into that, and a lot of abuse happens not only of the land, but people. And so I mean, to be honest with you, I'm not going off topic, but I'm working on a science fiction novel as well, and one of the ideas is that we should localize food production because I don't even know what I'm eating.
Exactly.
And as you said rightly that we don't have of course you can have it, but we all don't have a school in our home or a church or community center or a playground. We share those infrastructure which are local, and this could be a very good example of taking control of our food production as well. Now, how the food companies will respond to that is a totally different topic, but I think this is a great idea for a sustainable society.
Right.
Where you can, and it's also about the way you're working on the model that you are not limited to the food that grows here. You can grow virtually everything. I can grow mangoes here, which I cannot grow.
Exactly. So you can have maybe you can either have a whole kind of world ecosystem in the basement of a building or something, or you can have maybe this school does mangoes, this school does strawberries, kind of cross collaboration with those, and then learn best practices from all those things. And I think the broad scale of agriculture and the broad scale of hydroponics or whatever kind of system you're using to grow plants is pretty standard, but like how you apply that to a specific like group of people or a specific family or something like that can be very different. So you can say, okay, we're using these methods to do this. We're going to work with you guys to use these methods to do this, and then kind of learn from each other and then apply those back to your own principles.
And since all of it is using IT and all these technologies, it's all distributed but connected world. So you
Yeah.
don't have to actually literally go and talk about it. And I'm assuming that all the information which is without the sensor. I mean, the more you use, the more you learn, and it goes into some kind of your database. So I don't know whether you will be using at some point deep learning also, that you don't have to do things manually on Raspberry Pi to turn the sensor on or not. There may be pre-programmed. Okay, this plant this kind of environment, and
Right.
you have a set module for potatoes, module for tomatoes, and then it's all connected. So you can grow whatever you want. You don't even have to ask. You can just okay, you're growing this, we are growing this, we are growing this, and does that make sense?
Yeah, definitely. I think that is a definite possibility in the future. Like, I think that like using technology for to like benefit people is kind of the goal, right? We're using a lot of technology to benefit ourselves a lot, I think. But if you kind of look past what we're doing now and kind of into the future and what technology is trying to like branch into, like you can see these greater communities using stuff, and like you can see that with open source, and if someone's developing something and people contributing to it and kind of managing it and then just like joining in because they think it's cool. And I think farming and like agriculture and food systems can be a similar model like that.
Because I remember Jim Zemlin, he's the executive director of Linux Foundation. He said, the open source is all about bettering yourself by bettering everyone else. It makes so that's the only way it works.
Yeah.
You make it better for everybody else when you better. How and when did you get involved with the project?
So I watched a TED Talk by who I guess he's the principal investigator of the MIT Media Lab group, and I thought this technology was super cool. I had known a little bit about open source stuff in general, but hadn't really done that much. I did some coding in college, but didn't really like it that much. But I saw this TED Talk and I'm like, oh, this is so cool. Like you can create your own environment in a box and grow plants basically, and then kind of build on that and iterate it and change the taste and all this stuff. And so I kind of looked at all the stuff, and it's open source. I was like looking at the code, looking at the bill of materials. I'm like, okay, like this is pretty doable. Like I had done some prototyping stuff in college. I'm like, okay, let me try and build one of these things. So did some Code Academy Python classes, learned a little bit about Raspberry Pi, built one of the food computers. And like, as I was doing this, I was like, this is like something really cool that I think there's a disconnect a lot of times between using technology for the sake of using technology and using technology to actually do something. And so I thought that using the food computers was a really good way to see how you can use technology to do something real. And so basically, based on like things that I had done in the past, really wanted to incorporate this into some sort of like school education system, and that way that could kind of be a sustainable model for people to get involved with something like this. And then had developed some curriculum, approached a school, local public charter school in Baltimore, to say like, hey, I think this is a really good idea. They were on board, and then just kind of happened. So
how are you're talking about sustainability of food, but how are you making the project sustainable?
Yeah, so basically, for now, so it's within the student science classes. So they have like the school that I'm teaching at has kind of different career interests that students can choose, and so one of those interests is agriculture. So if the students are in the agriculture career segment, they're taking the food computer class as their science class. And one of the things I've realized over the past few years of teaching these classes and teaching at this school and elementary school and middle school is that the students really like having the opportunity to like talk with people about what they're doing, but also learning from them at the same time. So what I've started to do is have like volunteers who are either like developers in the area or college students in the area helping teach these classes as well. And so then you're kind of building this community of students learning stuff that's applicable to their communities, people from the outside communities coming in and seeing what students are doing, and all of them like building stuff on each other. And so in that way, kind of, so it's not just me teaching the classes, and it's not just one class of students learning the stuff. It's kind of a rolling model of, okay, you have these students doing stuff, building on top of it, cooking with the food that they're growing, and then you're having other people come in from the community and kind of seeing what they're doing to get involved in different areas.
We talk about all the way to Mars and future. What are the immediate challenges that you have? Or I mean, you did mention, you're learning, the model is learning, try to, and so number one is what are the immediate challenges that you're facing? Number two is what are your immediate kind of goals that you want to achieve, or this is your focus for now?
Challenges in terms of like running the program or the students, or
I mean, when you build this program, there may be a lot of challenges that you come across. I'm sure it's not as smooth.
Yeah. So I think a lot of the challenges revolve around like unexpected stops in prototyping things that we're doing. So we had essentially build these computers out of like foam boards that the students have to cut up. First time I did this class, I had everyone have those box cutters, cut up all these boards, and it took literally a week for everyone to like cut up just 2 foot by 3 foot squares of this board. So kind of building on them, okay, there needs to be a better way of doing this. So we brought in some like tools like circular saws and stuff like that. So we did it in 30 minutes instead of 4 hours. There were some instances, so after the students in one of my classes had built the regular food computers, we wanted to kind of scale it to see, okay, this is cool that you can have this food computer that has maybe 10 to 15 plants, but how does this apply to real life? So there's a room in the school's basement that no one's using. So they're like, okay, you can use this to like cut up stuff and get dirty, like cut wood and foam and stuff. So we basically built out like a room-scaled food computer in that room. The students kind of designed it by themselves. They're like, okay, it'd be better if we could put all these basins together, and so we have a continuous water flow of stuff. It'd be good if we could have multiple shelves of stuff so we can grow more plants. So they designed it all. We like bought all the materials, we put it together. We filled it up with water to test it out, and it all just like leaked everywhere. And the students were like, oh my God, we're failures. But then we're like, okay, this kind of works. It just like doesn't work all the way. So kind of used it as more of like a learning tool and say, okay, this didn't work, but what were the reasons why? The plastic that we're using was really weak. We didn't seal all the pipes that were pushing everything together. The pressure from the water coming up into this flow was a little bit too strong. So we spent the next month like redoing it, rebuilding it, and then now it works.
Yeah,
great.
all the expected problem with the prototyping, anything,
Yeah.
I mean, because there is no playbook to follow. So
Right,
so
exactly.
That's hard. But that was also not technology problem, right? That was because technology problem has been always solved for you with Raspberry Pi and all those things.
Yeah.
So that was the challenge. What is your immediate, goals that you want to achieve? Hey, this is our, or these are the milestones that we want to achieve as we go forward.
Yeah. So the major things I want for the students to just realize like what they can do with like computer coding, and that it's not just typing on a screen or kind of moving these code blocks around, even though you can learn a lot in terms of process logic and stuff in that way. I think the more gratifying aspect of that is being able to do something physical with it. So if you can say, okay, we're taking all these like hello world type physical computing things with Raspberry Pi and Python, now let's do something with it. And I think the thing that I want students to do is say, okay, here's like a way to achieve this end goal. Like if I want to run a restaurant when I'm older, I can buy food from this restaurant Costco place. I can grow my own food. I could maybe use technology to grow food or do stuff like that. So I think the immediate goal is for them to just like have fun while they're using the technology and realize how it can help in a real world scenario. And so that in the future, when they're doing whatever they want to do, they have that kind of in the back of their mind saying, oh, okay, yeah, I remember when I was doing this coding stuff. I remember when I was talking about food systems. I think, for example, like Lyft recently started a program in Baltimore. I don't know if it's in other places where they're basically providing discounted rides for people to go to grocery stores, trying to solve like this food desert problem in Baltimore. And like Lyft is a ride-sharing company. It doesn't have anything to do with food systems, but someone in the company like had this idea and said, hey, this would be a good way to apply what we're doing. So I think in the future, what I hope for my students is that whatever they're doing, they have this in the back of their minds saying like, okay, I know that these are challenges and I know that technology and other things I'm doing can help solve those things, even if it's not directly related. I think one of the cool things for the students is that they've like built these projects all by themselves. It's something that isn't really done in a lot of other classes, or at least traditional academics. We have kind of this model of learning lessons, having tests, having standardized exams, moving on to the next grade, moving on to the next step. And the food computer program is really unique in that there's not really like exams that you have to get a certain score, or there's not really like testing that you have to do. And the goal is for people and the students to basically just like explore and kind of learn about all these things and how they can use their own like creative thinking and all this stuff to build the food computers and say, okay, now that I've done this, we've grown basil. And so now that we've grown basil, what do we do with it? We can make pasta, or we can make an omelet. And now that we've made pastins and omelets and sandwiches and pestos, like what else can we do with it? Oh, we can maybe like sell these sandwiches and like run a business based off of sandwiches or something like that. So I think the cool thing is to see the progression of students thinking like, okay, like farming is interesting, like maybe I'm interested in this, I'll try out this class. Going to like computer programming, so like, oh, this is cool, you can control all these elements and take photos and do stuff with computer programming. Then the progression to say, okay, like now we've grown a plant from a tiny seed to this huge like kale, I don't know, plant. And then now we can like do other things with it and seeing that progression of them figuring out all these things and learning all these things and like kind of building on all of them is something that's really cool to see.
I think we have covered, what you do. I mean, to be honest with you, this is a topic where we can talk for hours and hours because there's so much scope. But I look forward to talking to you again. But before we wrap this interview up, though I know this is your passion, where you're investing a lot of time, but what do you do in your free time if you do find any free time? What are your hobbies?
Free time. I love running. So I picked up running a few years ago and like to run half marathons. And I think it's kind of cool to, it's something that you can kind of quantify. So you can say, oh, okay, I've run this speed. And now next week I'm going to try and run this speed. And the next week I'm going to try and run this speed. And these are like techniques that I can do to run faster. And so that's something that's really fun for me. I do like playing around with Raspberry Pi. So I get there's a Raspberry Pi magazine that comes out, I think it's every month. And so whenever it comes in, I'll kind of read through and see what other people are doing for projects. And sometimes I'll take some of those and try to incorporate stuff we're doing in the class. Sometimes I'll just do it by myself and be like, oh, this is kind of cool. Like, I should use this for something else. Like one of the projects was building like a Google Home device with the Raspberry Pi. I'm like, oh, this is like you can do so many, like there's so many things that you can do. There's like not enough time, so.
Thanks for talking to me today. And but the project that you're working on, I would love to keep in touch so that we can learn more about the project. So once again, thanks for talking today, and I look forward to talking to you again.
Yeah, thank you so much. This is great.